Good afternoon. My name is Nikita Oberoi, and on behalf of the National Academies of Sciences, Engineering, and Medicine's Climate Crossroads Initiative, I am pleased to welcome you to the 4th Annual Ramanathan Climate Conversation. I want to start by thanking everyone online and in person for joining us, and a special thanks to Scripps Institution of Oceanography and the organizers of RAMFest for including us in this distinguished group of leaders and changemakers to celebrate RAM. Ramanathan Climate Conversations are an annual series in honor of National Academy of Sciences member Dr. Ram Ramanathan and are made possible through the generous support provided by Sunanda Basu. They are part of the Climate Conversations Pathways to Action monthly webinar series from the National Academies, which aim to convene high-level, cross-cutting, nonpartisan conversations about issues relevant to climate change. Recognizing that climate change is a global challenge that requires global solutions, Ramanathan Climate Conversations focus on climate resilience in South and East Asia, aiming to identify pathways to action relevant to viewers and decision makers around the world. Our conversation today is being live streamed and recorded. We'll have a live Q&A during the final 30 minutes of this session. For those in person, we'll be using the microphones in the room and we'll be alternating with questions here and online. For our online audience, please submit your questions at any time using the Slido box below the video. As a reminder, the views expressed in each conversation are those of the participants and do not necessarily represent the National Academies. Today's climate conversation will be exploring the interactions between air pollution, climate change, and public health in India. To kick us off, we are honored to have Ram himself share a few words about his vision for the dedicated Ramanathan Climate Conversation series. Ram, the floor is yours.
Thank you, Nikki, and thank you for the National Academy of Science. My vision is very simple. Listen and learn from the experts. That's why I'm here. I first of all also wanted to thank the donor, Dr. Sunanda Basu. She is an ionospheric physicist, and she was an administrator, grants at the National Science Foundation. I met her because I was going to somebody else's office. By mistake, I went into her office, and I found she was a former Indian. So as immigrants, we don't say, oh, I didn't come to see you. So I tell her that I came to see you, talk to her, and started a long friendship. Thank you, Sunanda, if you're listening. The topic today is just tremendously important in everything we know: health, environment, climate change. And so I'll just let you know one issue in climate change. It's well known amongst the experts here. Somewhere between 30 to 50% of the heat trapped by these gases have been masked by aerosols, because what do aerosols mean? You see them, particles you see, gases you can't see. That's why my view is this heat trapping gas by increasing, we can't see it. You saw Kim Prather, how she showed. So these aerosols are masked, we know that. How much is still largely uncertain, somewhere between 30 to 50%. What does that mean? When we clean up air pollution, there will be a huge acceleration of the warming. And the way to avert that is what Gabby Dreyfus, Durwood Zalke, myself, David Victor, Kim Prather have all been saying. As you cut down air pollution, also cut down the short-lived pollutants, you will offset the unmasking. But India's air pollution, unfortunately now, is one of the most severest. It used to be in China. China is cleaning up, and some of the rapid warming is attributed to that. So I want to introduce Jen Burney, the chair of this. Jen, when she finished her PhD in physics, did I get that right? At Stanford, she wrote to me, and Bill Collins yesterday said, the way I decide to hire postdocs, I look at the thesis, if there are at least 10, 15 equations, I hire them right away. So Jen has done some incredible work on linking air pollution to agriculture, yield, climate change, their emission histories and all that. So I'm looking forward to it, Jen. Thank you.
Thank you so much, Raman. Thanks to everyone, both in the room and online, for joining us today. It's an extreme honor to be part of this panel, especially that it coincides with our celebration of Ram's continued scientific legacy. I just quite simply would not be a scientist today if Ram hadn't taken a chance on me. So this feels like a wonderful way to say thank you. And we are here today with an incredible group of panelists to talk about air pollution in India. Poor air quality remains one of the most pressing environmental challenges and public health challenges in India today. It's driven by emissions from a wide array of sectors, from energy, industry, household emissions, and agricultural practices. We're going to hear more about this. And as Ram noted in his introduction, it has very complex interactions with climate change in multiple dimensions that we will get into. Why are we thinking about this in India? Of course, it's both a function of the magnitude of the problem, which we will get to, but also maybe an expression of hope, right? Insofar as if we can think about ways out of this complex problem in India, I have a lot of hope for the world as well. So we are here because we think it's important to gain a deeper understanding of these complex dynamics between air pollution, climate change, and human health, and to think about how we can move forward with solutions that address all three at once. This afternoon's conversation is going to explore these dynamics, and we are very lucky to have three fantastic panelists for this conversation. So I'm going to start here in the middle with Pallavi Pant, is an environmental health scientist with more than 15 years of experience working on air pollution and health, and particularly in low and middle income countries. Her research has focused on air quality, source apportionment, and exposure assessment, and she currently serves as the head of global initiatives at the Health Effects Institute. Thank you, Pallavi. Next to me, Meera Mahadevan is an assistant professor at the School of Global Policy and Strategy at UC San Diego. Her research lies at the intersection of development, energy, and environmental economics, focusing on public service delivery, infrastructure, and political economy in low and middle income countries. She currently works on projects on electricity transitions, water markets, and governance in South Asia. Finally, on the end, Meha Jain is an associate professor in the School for Environment and Sustainability and is also part of the Sustainable Food Systems Initiative at the University of Michigan. Go Blue. Jain's research examines the impacts of environmental change on agricultural production and strategies that farmers may adopt to reduce negative impacts. To date, her work is focused on the impacts of weather variability and groundwater depletion on agricultural production in smallholder systems, and whether farmers are able to adapt their cropping practices to mitigate these impacts. So thanks to the three of you for joining. By way of getting started, I picked a few photos just to orient our audience, because I think we talk about air quality and air pollution, and we're sitting here in Southern California, and we certainly have our own problems, but I think sometimes we're completely miscalibrated about the extent of the issue in India in particular. So this is a picture from Delhi, and while we usually think of World Health standards and different national thresholds as, you know, in the tens of micrograms per cubic meter of particulate matter, or the, you know, sort of the total mass of aerosol suspended particles in the air as kind of a health limit we'd like to be below, we're often 100 times that in a place like Delhi. And not just Delhi, but 10 or 11 cities, depending on when you look, in India are typically in the top 20 in the world. So I pulled up this picture just to orient us about sort of the magnitude of what we're talking about. And I picked a picture for each of you from your work, really, to cue up our audience and ask you this initial question. So how do each of you, from your own perspectives, your own disciplinary perspectives, how do you think about the links between air pollution, climate change, and public health? Pallavi, I'm going to start with you. And I've got this picture of a famous photo from the New York Times, really linked to our own Ram himself from a household cooking article that appeared about 10 years ago.
Jen, and it's really an honor to be here today and also to be at the RAMFest. As someone who grew up reading about Ram's work and learning from it and getting inspiration from it, to be sitting here is truly an honor. I think in the context of air pollution and health in India, I could start by throwing a bunch of statistics at everyone. The numbers are truly scary and big. Millions of deaths each year as a result of air pollution exposures, both outdoors and in homes, like the picture you see up here. But I think the part that we don't talk about very much and that we've also been hearing about this morning is this idea of what people are living with on a daily basis. For those of you who have family members that may be living with a chronic disease, heart disease, lung disease, cancers, these are all diseases that are linked to air pollution. And in the Indian context, we are a population that tends to have higher rates of diabetes, which, by the way, is also linked to air pollution. And over time, what we really see is these impacts manifest in many different ways. It is impacting the productivity of the nation and the economic output, but also it is impacting everyday lives of people. Someone may be doing caregiving for another person that is a loved one. Someone else may not be working because they have someone at home. And people are making choices every day of where they work, how they work, and what they do in order to deal with how air pollution is impacting their health. I think I'll just mention one story which probably perfectly illustrates this notion of what it feels like. A taxi driver in India who, or in Delhi, who's been on the road every day, 10 to 12 hours, experiencing the high levels of air pollution. And I was talking to him. He comes from like a hilly region, which is relatively much cleaner. And he said, well, I know this is problematic. I don't want to live with air pollution. I have headaches every single day, but this is my livelihood. And this is the only way I'm earning money and my family is able to live. So I think when I'm thinking about air pollution and health, there's huge impacts on all organ systems. Nothing different in the Indian context, except we are almost more than 1 billion people, so the impacts are much, much larger. We're also getting older as a country and as a population, which means we will see exacerbation of some of these impacts. But really connected to the health piece is the notion that so many livelihoods depend on the choices people are making. So it is a problem that we need to find solutions for, and we need to find them really quickly.
Thanks, Pallavi. Meha, for you, I have chosen this picture of stubble burning in a field. You're an expert in agriculture in India, smallholder agriculture, and the connections here. So how are you thinking about this issue?
Yeah, thanks so much. So first of all, thank you so much for inviting me to this event. It's an incredibly important topic, and I'm glad we're all here today to think about potential solutions. So just building on what Pallavi said, I did want to highlight these decisions that are being made are not ones that are being made lightly. The impacts of air pollution are very visible. They're being felt on a day-to-day basis, but oftentimes people have to make decisions that they know are not optimal just for financial reasons and to get by with their livelihoods. And I feel like this is very particularly well highlighted in the case of agriculture. So I'll just set the stage briefly for those of you who might not be as familiar with this system. So India has the largest amount of what's called crop residue burning worldwide. What this means is at the end of the growing season, oftentimes there's a lot of stubble that's left in the field. So particularly in northern India, farmers are planting rice in the monsoon season and then planting wheat in the winter season. And there's a lot of rice stubble that's left over at the end of rice production. But farmers really want to clear their fields as quickly as possible so that they can get their wheat crop in on time and optimize yields. And one of the fastest and easiest ways to do that is through burning. So as you can see through this picture, the air pollution impacts of crop residue burning are very visible. They're very real for the farmers themselves, the regions they live in, and also downwind. But this is really a difficult choice that farmers are making because of livelihoods. So just to throw a few numbers out to understand the magnitude of the problem. During peak season events, so this is usually rice stubble burning is occurring in around October or November, so we're approaching that time. Air pollution from crop residue burning can contribute about 75% of PM 2.5 values in large urban centers like the Delhi NCR area. So this is really affecting large swaths of the population. And one other thing I just wanted to quickly highlight is that even though, for those of you who are familiar with crop residue burning in India, the case study that always really gets a lot of attention and that's highlighted is this rice stubble burning that occurs in northwest India. But actually, if you look at the country as a whole, crop residue burning is increasing in different regions and for different crops. So this is becoming an even more widespread phenomenon. So for example, Madhya Pradesh is a state in central India. It's actually now the second largest contributor to crop residue burning in the country. And this is something that isn't always widely talked about.
Thanks, Meha. And Meera, finally to you. I picked this photo of a former representative trying to encourage fellow women to become involved in Indian politics. We just heard a little bit from Meha about stubble burning, about some of the tensions that are there between people, and from Pallavi trying to just make their way live and earn a living and protect their families. At the same time, we know that the energy mix in the country is still heavily coal and diesel dependent for transportation, but policies that might address that risk having a disproportionate impact. So as an economist and somebody thinking about political economy, tell us what you're thinking about.
Thank you so much for that. And it's such an honor to be on this panel. I think your question sort of tees up a very nice answer, kind of following up on both Pallavi and what Meha have talked about. So just to go back towards stubble burning again, this has become such a severe problem in the country. So to give you an example, what Meha mentioned, where there's this sort of popular discourse that a lot of this burning takes place in the northwest part of India. However, the pollution from this burning then spreads in a lot of the rest of the country. So for instance, even if burning occurs, say in September, we have winds that take this pollution and sort of cover a large part of the Gangetic Plain in India for months. And there's certain geographical features that sort of keep the pollution trapped. And so people experience this for months, no matter where it originates. And so therein lies the kind of complex problem with trying to control this kind of burning. So there's obviously several rules in the country. There's both the carrot and the stick. Sometimes farmers are offered cash incentives to not burn their crop. Sometimes there's severe punishments and fines if you do burn crop. But it brings us to the question of feasibility and enforcement on the more political and the governance sides. And this is very difficult to do because farmer lobbies are extremely powerful in India. And so it's not easy for a politician to then go in and try to enforce large fines on an admittedly very vulnerable, quite poor group in the country. And so something that tends to happen, and there's recent research on this, is very selective governance. So for example, if you live in the district and you know that wind patterns are such that the smoke is going to blow to the neighboring district, it's just not your problem anymore. You have no incentive to burn through your political capital and tax your farmers in any way when your constituents are not facing the brunt of the problem. And so the thing that makes air pollution something that requires government intervention, the fact that it has major externalities, it's not just the source of the air pollution that suffers from the problem, it's a much wider population. But that same fact also makes governance very hard because it changes incentives. And I think this is a somewhat less studied aspect of air pollution control, is who has the right incentives to actually control pollution. If I'm on the government side and it's in my interest to just get re-elected 5 years from now, I'm going to sort of focus on the incentives that align with that. And so to what extent can we as people, scientists, social scientists working on these issues, how can we sort of rethink incentives so that we're aligning everyone's to address climate change and to address reduction of air pollution everywhere, not just in these small areas. So that's kind of what I wanted to think about.
Fantastic. Well, thank you all for these introductory remarks. I'm going to put us back up here. And we're going to dive in a little bit deeper. So what I've learned both in preparing for this call with you three and in your introductory remarks, right, are that we have an incredibly profound problem. One, in just its magnitude. So I believe it was you, Pallavi, who pointed me to the statistic that we estimate that this is reducing life expectancies by about 5 years on average in India as a whole, which is just a shocking statistic, right? Second, this is a problem that ties together many parts of the economy, and the arrows don't always move together, and in fact, they're often very, very acute trade-offs when we think about this. So thinking about food security and energy and climate and air quality and environmental objectives, we have a wicked problem, to use the terminology. And then finally, we have a really tricky scale in terms of the largest country on earth, which is in many ways an incredible laboratory for distributed democracy and making progress in many ways, but also creates a lot of challenges when it comes to solving a problem that exists at a spatial and temporal scale that's much bigger than sort of the local devolved unit. So we really do have the confines of a very tricky problem, and I'm grateful for you three for leading this conversation. Meha, I'm going to come back to you to start. Agricultural practices, you noted, particularly crop residue burning, are linked to these severe seasonal episodes of pollution. But I'm hoping you could say a little bit more about how climate variability and water availability and food security concerns are really underlying these dynamics.
For sure, thanks for that question. So as Jen said, there are many trade-offs in this system. If there was a simple solution, it would have been adopted already. But unfortunately, something that might be good for reducing crop residue burning might not be the most sustainable, or it might not lead to the most food production. So just to highlight some of these trade-offs to exemplify the challenges, not only is India the largest producer of crop residue burning worldwide, it's also the largest user of fresh water worldwide, and there is rapid and severe groundwater depletion in many parts of the country. At the same time, food production is being negatively impacted by climate change. Specifically, wheat is one crop that is really negatively impacted, and India is the second largest producer of wheat worldwide, and it's really kind of the backbone for food security in this country. So it's a challenging place for many reasons, and there are trade-offs across these different dimensions. So in considering groundwater, the government actually instituted a ban in Northwest India in 2009 that said that farmers could only plant their rice crop after mid-June, after the monsoon rains had arrived. And by doing this, farmers ended up using less groundwater. They were more reliant on the monsoon rains, which will have arrived by that time. And studies have shown that that has been good and improved groundwater reserves. However, one trade-off that's happened is once farmers plant their rice late, they then have to harvest their rice crop late. And this shortens even more that time period that farmers have to prepare their wheat fields. So actually there was an unintended effect from this groundwater conservation policy where there actually was much more increased residue burning. So this is just one kind of highlighting of these potential trade-offs. Another way that climate change is impacting this system, so I mentioned wheat is one crop that is really negatively impacted by warming, specifically warm temperatures that occur in the spring around March and April. And studies have shown, including some of our work, that one of the most effective ways to reduce the negative impacts of this heat stress is by planting your wheat crop a little bit earlier, by early to mid-November. But once again, what does that do? It constrains the time period between when you harvest rice and you prepare your wheat fields, and this once again sort of incentivizes crop burning. So we really need to find solutions that can think across these multiple axes and can potentially find win-win-win solutions. And I'm hoping we can come to some of those at the end of this panel.
Fantastic. Well, I'm going to pass straight to Pallavi and ask a similar question. We've been talking about crop residue burning, but also there are a lot of different sources of air pollution affecting air quality and human health in India. So I'm hoping you could say something about some of the other major contributors and some of the trade-offs you see from your perspective thinking about public health interventions.
Thank you. Do I get an hour to talk about this with all the sources? But I think some of the major ones probably worth highlighting are electricity generation. I think, Jen, you already mentioned coal is still one of the biggest sources of energy we're using. In a country of 1 billion people, there's also waste that is generated. And with not having really good waste management solutions, a lot of that is getting burned. And I think one piece to really be thinking about is similar to the farmers who are very close to these fields that get burned. There's a lot of communities, and often under-resourced communities, that live very close to places like landfills, which are often continuously burning. And there, we're not just thinking about the traditional criteria pollutants like PM 2.5 or nitrogen oxides. It's really a cocktail of a whole range of pollutants that we know can cause cancers and a variety of other health effects. The other one, perhaps, that is the most critical in some ways in the Indian context is also the use of solid fuels like wood, animal dung, and in some cases coal for cooking, in some cases also heating, because a significant proportion of the country's population still relies on these fuels to cook and eat every single day. And this means that a lot of people are getting exposed continuously to those high levels. Also, given the social structure of the culture, we have women responsible for cooking most of the time, women often also responsible for gathering the firewood that they're going to use, and women are also the primary caregivers. So both women and the children, the infants, are getting exposed to these high levels of pollution. And what we know from science that has been done both in India and elsewhere is that if there is high exposure during the early stages of development, going all the way from pregnancy to the first 1,000 days of life or the first 5 years of life, that's really going to cause problems for these children for the rest of their lives. It could mean lower lung function, poor lung development. Their organs and immune systems are really developing at this stage. So getting exposed to pollution means that they may be more prone to chronic non-communicable diseases in the long run. So it's a whole range of health effects that we could be thinking about, and that cuts across any source of air pollution that people are getting exposed to. I'll just cite one statistic, which I think again is really powerful. A lung specialist in Delhi who's been practicing for over 30 years, has been, operating on patients that have lung cancers for a long time. He started noticing that he was getting patients that were younger and non-smokers and women. And he started looking at what that data really meant and why that was happening. And then he realized over time that it was really increasing levels of air pollution exposures that were starting to contribute to cases of lung cancer in people that are never smokers. And have only been breathing in the polluted air. So I think it is a problem of really epic proportions. And the piece which I think we need to be thinking about in the health context also is that our health system in the country is not equipped to deal with the burden that air pollution can bring. Meha mentioned October, November as being the period when pollution levels are really high. That's when we see a lot of people experiencing respiratory distress, more people experiencing heart attacks, and the health system needs to be better prepared. So I think it also goes back to the resilience point of how do we not just think about air pollution as what are the sources and how do we fix them, but how do we create better systems that can deal with the problem as it happens.
Yeah, thank you. In many ways, Meera, you're the perfect person to turn to from that, which is right what you two have articulated. Thus far is the deep interconnectivity between, development and sustainable development and this profound air quality crisis that's smoldering on and on. Meera, how do you think about this from your perspective as an environmental economist? How do we think about balancing growth, energy access, electricity access, all the things that we know contribute so many positive outcomes with the reality of also their negative spillover effects and the reality on the ground?
Boy, I wish I had an answer to that. It is a tough problem, and I think it would behoove all of us to sort of approach this problem with some empathy. So, for instance, it's easy to say things like, you know what, we have science on this. We know air pollution is bad. We have science on this. We know that we have better technology out there. We have solar panels. We have potential hydropower that we can harness, and a country in which both of these have a lot of potential. However, there's two significant problems. One is a large part of the country lives in extreme poverty and vulnerability. So to give you an example, there's parts of the country that are still not electrified. We know without a shadow of a doubt from research the massive development benefits that having access to electricity can bring us in terms of health, in terms of education, in terms of lifetime income, in terms of life quality. So these people don't even have any electricity. One potential solution and opportunity for us here is to say we're a country where we want to advance the development of these people. We're also facing a significant air pollution problem. So instead of depending on a coal-heavy grid, why not electrify these villages with a cleaner form of electricity, like microgrids? They are located in the villages sort of take care of them. There's various models. There's more than 100 startups in India now marketing these solar microgrids. To give you a few examples about why this hasn't worked. One, there have been some villages that are stuck with these microgrids now and absolutely no follow through. So the startups go out of business. There were millions that went out of business during COVID, for instance. Now there's villages that are stuck with this sort of deteriorating infrastructure, zero know-how on how to maintain or fix them. Increasingly, villages are now refusing these overtures. And there's multiple reasons for this. One is this historical precedent of it not really working out. And second, the slightly more sort of almost human part of this, which is villages will sometimes say, no, if we accept this offer, even if free for a solar microgrid, it means the government is never going to extend the central electrical grid to us. So I think it helps to sort of approach this problem as also seeing these people as people with aspirations and people who want to be whole a part of a country that is growing and to be able to get some of those benefits. That's one problem, that we can't really fix some of these issues with just the science. It's not enough. We need a little bit more follow through. To give you another example of follow through in urban areas, the government has, both the central and state governments have often announced policies very ambitious on the face of it. So for example, the government of Karnataka, which is a southwestern state in India, announced a plan saying, we are aiming for 30% coverage of rooftop solar in the city of Bangalore by 2030, which sounded unbelievable, and it was unbelievable. And to give you just a couple of examples, I remember my parents' neighbor came and said, we've been trying for years to get rooftop solar, and the government has this directive, there's subsidies available to people. So there's this sort of supposedly top-down support for this policy, except that no one told the local utility. So they have absolutely no people who know how to install solar. They have absolutely no people who know how to set up net metering to complete the loop on what it would mean to have rooftop solar. So I think we're stuck in this rut of wanting to do something, but not being able to follow through and sort of really take on what it means for these policies to actually work. So I think this is a tough problem, but I also don't see it as an insurmountable problem. I think, coming back to what I'd said earlier, there's this question of incentives. A politician gets a lot of mileage for being the person who goes on this global stage and says, we're a country that's doing so much. Look at how much solar we're putting out there. Look at how much we're doing for air pollution. And lo and behold, I get reelected. Well before the deadlines I've set for some of these plans, we're just not aligning these political and bureaucratic incentives with the real timelines that we're working with to actually change things. So to give you a very small example, with rooftop solar, how difficult would it be to have a policy and then get people involved who know how to do the actual manual task of installing solar? There has to be training for people. People have to know, in addition to what subsidies are available, what is the practical sort of side of this? How do I make rooftop solar work in my home? And I think there are people who know how to do this and just need to be brought on board, rather than getting stuck in this sort of infinite political cycle that we are.
Yeah, thank you so much. In true scientific fashion, we've done an incredible job laying out the landscape of how hard this problem is. But I'd also like to surface the reality that I think we've done a very ROM thing here, which is to illustrate why you have to have different people with different expertise all in the room talking together, because the reason these problems are hard or historically seem hard is that it has been rather siloed in terms of approach, and we're learning from everything you all have laid out, of course, right, how everything is connected. And so while you are perfectly the people to lay out the difficulty of the problem, you are also three people who've had a lot of success in thinking about actually implementing real solutions that work because they take this context into account. So I'm going to start now turning towards the hope and solutions part of this panel with Pallavi. I was hoping you could start us off by talking a little bit about the role that monitoring and reporting have played and what you view as sort of the role for that kind of on-the-ground scientific monitoring and measurement for reducing air pollution.
Yeah, thank you so much for that question. And I'm going to start by sort of going back in time to when I was doing my master's, and that was the first time I started working on air pollution in India. And the only way that you could get air quality data for Indian cities was by going to the Central Pollution Control Board. They have their office, that's sort of the EPA equivalent in India, and they had these big books that you could copy the data from. So you could sit there all day, digitize the information, and then go do whatever you want with it. If you wanted data from the meteorological department on weather parameters, you could do the same thing. So I actually sat for days at end in both these offices trying to gather the data, digitize it, and then use it for the analysis that I wanted to do, which, by the way, at the time was very, very basic. I wasn't running sophisticated models. I just needed average daily PM 2.5 data or PM 10 data at the time. PM 2.5 did not exist. We weren't monitoring it yet. Fast forward to today, we have over 500 real-time monitoring stations across the country. Not nearly enough for a country as big as India, but it's a big leap forward. And we also have manual monitoring stations that have existed for a long time. There's forecasting systems that have been developed for several cities, emission inventories that you can relatively rely on and use for any kind of work you're trying to do. So I think especially in the last decade, we have made very big advances in how air quality is being measured, what we can do with that information, and how it can also feed into the decision making. So that's one area where I will say there has been success. Of course, there's gaps which we continue to fill, but I'm willing to revel in the success because it is progress, and it's progress in real time. Some of that data availability has also meant that we are now able to better track sources of air pollution. So even with crop residue burning, one of the ways that people are really using the data sets is from the ground monitors, low-cost sensors, which are also telling us what is the situation in the very local places where crop burning is happening, because often the conversation tends to be, what's the impact in Delhi? Because that's where the people that can make the noise are and people that can write the newspaper articles are. But what is the impact in the village where the burning happened? And we do have a lot of people now with labs that are capable of doing monitoring to try and understand those problems. And all of it has fed into developing programs like the National Clean Air Program, which was launched in 2019 with one objective being we want to expand monitoring. And that's one area where I would say the country has been pretty successful. And hopefully we will continue on that pathway of trying to gather better data and then use it to make decisions that mean the most. The other really quick example I will give, which is not so much on the air quality data side, but on the health data side, is that within the Ministry of Health and Family Welfare in India, the National Center for Disease Control now does surveillance for air pollution related diseases. Again, this did not exist 5-10 years ago, but we do have that now, and it's a beginning of a program that can become nationwide and again help make better decisions.
It's fantastic, thank you. Meha, turning to you, I was wondering if you could say something about the actions that are happening also at the regional or local level on the agricultural side.
Yeah, for sure. So even though we've painted maybe a kind of bleak and challenging picture up until now, I do want to echo Pallavi's point that I think there are reasons to be optimistic. So this hotspot of residue burning in Northwest India that we've been talking about a lot today, some studies have actually shown that the amount of burning is stabilized or potentially even started to decrease. And this is for a variety of reasons, but some of them are because of the promotion of different technologies or seed varieties that can help with this problem. So specifically, there's something called the Happy Seeder. What it is it's a tractor-mounted technology that can actually pick up rice stubble, chop it up into little pieces, basically mulch it, plant the wheat seed into the field, and then place that mulch over the wheat seed. And people have shown that if farmers adopt Happy Seeder, it reduces burning because now farmers have a way to deal with that stubble. It allows farmers to plant their wheat crop on time, enhancing yields. And it can also lead to soil improvements because you have this mulching, adding additional nutrients to the soil. There are a lot of organizations that are trying to promote the adoption of such technologies. So the government has subsidized this technology because it is very expensive. You also have to have access to an expensive tractor. And then there are also organizations like the Nature Conservancy and various CGIAR, which is an international research group, working to promote these solutions at scale. Another potential benefit or kind of potential solution is switching to shorter duration rice varieties. So what these have been shown to do is it saves groundwater because the rice crop is in the field for a shorter period of time. It is harvested earlier, which once again reduces that constraint to needing to burn to plant wheat. And this is potentially an additional strategy. And this year in particular, I read recently that normally only about 15% of area in Punjab is under these shorter duration varieties, but this year actually about 50% was because there was a flooding event in July, which led to the failure of the initial rice crop, and farmers came in and planted this secondary shorter duration crop. So, it might probably, it did or will lead to reduced rice yields, but we're hoping that it will lead to reduced burning. So I think there are solutions. I can elaborate more during the Q&A of additional ones, but I think there are strategies out there.
These are really excellent examples because they sit really at the heart of the individual stakeholders' experience and build out from there. Pallavi, you also, I think, had some examples about individual and community stories of success in terms of advocacy and welfare groups. Could you say a little bit more?
Definitely. So I think one of the ways in which we've seen a really big spotlight on air quality issues in India has been through community groups and advocates. So I'll maybe mention a couple, and I'm happy to talk more about them afterwards. One is a group called Warrior Moms. And the words are pretty self-explanatory. It's a group of moms that were really concerned about the quality of air that their children were breathing, and they have been very, very diligently advocating for the need for interventions to address air pollution, but also recognizing that policy interventions can take time to be implemented and then to see the results. They've been thinking about community interventions that they can help people undertake already. One example, which I thought was really neat and interesting, was that they were working in a particular community trying to encourage people to go for a community kitchen where there would only be one central kitchen. Every household in the neighborhood can come and cook there. It also made it easier to provide cleaner cooking solutions because it's only one place. And it meant that mothers were not taking their children to individual, often solid fuel using, cooking areas. So there's many examples like that, which I could, talk about. The other one I'll mention really quickly is we've also seen specific sectors becoming really involved. So construction sector, which also is a really big issue of, source of air pollution in India. There was a group that worked with women construction workers to train them on air quality, and then to hand them monitors and then let them sensitize their community, give them ideas on how to reduce their exposures, what to advocate for when they're working. And that again has become a really powerful example of if the right people have the right information, they can bring change themselves. They're not going to need people like us to do that for them.
That's fantastic. Once again, you've perfectly teed up Meera to answer this. Your own work, Meera, has looked at this intersection of government innovation and environmental outcomes in India. So would you say a little bit about what you have learned for us?
Yeah, happy to. That was the perfect segue. So in the vein of sort of talking about more optimistic results and, where do we go now, we have some recent research that shows a very strong causal link between the election of women leaders at local legislative level in India and a significant reduction in the practice of crop burning. By as much as 13%. So in legislative areas in India that managed to elect a female leader, narrowly defeating a male leader, and that kind of helps us make a claim that there's a causal effect here of electing the women leaders. We find a 13% fall in the practice of stubble burning and a close to 40% fall in the follow-through particulate matter resulting from burning. And we managed to do a survey. So I do want to take a step back. So this isn't research that says women somehow did the job better. It's about saying that there was a very specific reason why this worked in this context and what might be learned from that. So we did a survey in the state of Punjab, which is historically one of the more patriarchal societies in the country. And in order to encourage more female representation in politics, they instituted a reservation of seats. So 50% of seats in local legislative offices in Punjab are reserved for women. We were able to do a survey, and fortunately, because of this reservation, we have equal number of male and female voices in these leadership roles. And we find an extremely strong link between these women's actions and their concern for child health specifically. So this is not to say that the male leaders were not concerned. They were just much more concerned about things like farmer welfare or soil health, which are important, but these are concerns that we've seen represented for decades. What we had not seen was an increased focus on the effects of air pollution on child health, which seemed to come far more strongly from these female leaders because of two reasons. One is these female leaders, themselves women in a patriarchal society, were the sole childcare providers in their own households. But they were also elected by a predominantly female base for whom this was an extremely important concept. And this was very successful in reducing stubble burning. And we tried to ask them questions like, how did you manage this, right? For example, what Meha was talking about, we have the science in some aspects, we have technology like happy seeders that the government is trying to subsidize, but an enforcement challenge that we've been facing is that there's not enough happy seeders, and even after the subsidy, they still remain expensive. These women just sort of solved this problem by this kind of internal coordination, by matching farmers who needed to clear their stubble quickly with neighborhood livestock rearers who could use that stubble to feed their livestock. And so they managed to outsource labor in terms of clearing the field quickly in the absence of technology for a perfectly legitimate need to feed their livestock. And that's sort of how they managed it. And this is a huge fall. And so it just makes me think about the extent to which we should be expanding this focus, especially in a day and age when diversity is such a dirty word. How do we think about the fact that climate change, air pollution, has impacts on extremely vulnerable groups? What happens when we put the agency back into those vulnerable groups? The people who are truly affected by the ill effects of climate change are not those that can afford to travel in cars with AC and live in homes with air purifiers. They're people who live in very rural areas. They're people who have tiny children. They're people who are forced to cook with firewood. And so I think we need to think about diversity in policy making through a slightly different lens. Who is affected by climate change? Who is affected by air pollution? Are they being represented in politics? Are they being invited to the decision-making table, and do they have a say in how our policy is designed?
Excellent, thank you so much. I think we're going to move into the Q&A part of our session. So I'm going to invite our NASM leader, Nikki, back up to help moderate the Q&A. And we'll alternate questions, I believe, from online and in the room, and I'll feed them appropriately to our panelists.
Thank you, Jen. Thank you. The first question that we have is from an online audience. The reduction of air pollution, specifically aerosols, can accelerate the impacts of global warming in some regions. What do you want stakeholders and organizations to understand about this reality?
All right, excellent question. So actually, probably all three of you could speak to this, but Pallavi, may I start with you on how do we think about this trade-off of cleaning up the air unmasks this acceleration in warming that will undoubtedly transpire?
An excellent question, and probably something we could spend a lot more time talking about. But I'll maybe make two points on this. One is, at least in the Indian context, we are already seeing that the joint effects of air pollution and extreme heat are much worse than what we would see from either one. And if we are truly thinking about improving public health, and we're thinking about improving quality of life for the billion-plus Indians, then we need to continue to reduce air pollution emissions while taking into account what we need to do to address climate change. And at least in India, we know for sure that a lot of the sources are really closely linked. We also know that there is sufficient opportunity for joint action on both problems. Even in the Indian context, we've had very parallel and siloed conversations around climate and air. So perhaps it is time for us to think about it as a common problem. And if our goal is better quality of life for all people, then this is not a this or that question. It's really, how do we get to the best possible, cleanest air that we can get for everybody involved?
Yeah, Meha, I was going to invite you to say something as well, because I think one point of positive convergence here is potentially in agriculture, with not just, we think about the climate impacts of aerosol cleanup, the unmasked warming, but we could also think about almost a repair of the monsoon circulation as a potential side effect.
Exactly, yeah. So there could be, a lot of different impacts on agriculture. First of all, a reduction in pollution. Jen has some amazing work showing that air pollution directly negatively impacts crop yields. So if we clean up the air, hopefully that would improve crop yields. Potentially, we would have a return to monsoon patterns that are kind of less detrimental to current cropping practices. So as I mentioned earlier, this year we had a really kind of heavy rainfall event in July, and this led to the washing out of the originally planted rice crop. And what climate projections and attribution studies have shown is that because of climate change, what's happening with the monsoon rainfall is it's becoming much more intense on the days that it falls, and we're getting these really heavy rainfall events, which are bad for agricultural yield. One thing that I will say that I am a little bit worried about is, if we do have increased warming, I did say that wheat is one crop that is already really negatively impacted by warming temperatures. But I do think there are solutions out there to help farmers plant their wheat crop earlier in a way that doesn't lead to crop residue burning. So it's a challenge, but I think that there are solutions out there, so I'm hopeful.
Do we have any other? Yes.
Actually, this session is about air pollution, climate, and health, and I believe that it is because health is so much important to the livelihood of the people. But actually, especially for India, the environmental parameter, the utmost importance is water availability and precipitation. And air pollution is known to affect rainfall in India in many ways, both radiative and by microphysical effects, both by teleconnections and by effects of local radiation budget, and Ram has addressed that in many of the applications. And actually this is, as already was highlighted, the aerosol cloud interactions is the least known interactions, especially while we claim it with respect to Earth's radiation budget, it is even less known with respect to precipitation. It has big impact, no doubt, but we don't even know how to quantify it. And I don't hear much about it. How do we address this?
Yeah, Danny, that's a wonderful question. Thank you. I'm going to ask Pallavi to speak first, and then Meera. You've just talked about this incredible expansion of sort of monitoring, reporting, public data gathering. How does it speak to this intersection? And then Meera, I'd like to have you ruminate on what it means for policymakers trying to do the right thing under tremendous scientific uncertainty, both under current pollution loads and thinking about cleaning up aerosol loads and what happens as well with a warming atmosphere but lower aerosols. Thanks.
Thank you very much for that comment. And I think what you're raising is really critical. The way that I see it to some extent is that the aerosol science field in India has been rapidly expanding. If you look back at publications from maybe 10, 15, 20 years ago that were being done at majority of Indian institutions, people were measuring one site, gathering data, publishing, here's the levels of particulate matter or nitrogen oxides. And we've really made a lot of advances in the last 10, 15 years on what people are able to measure, the sophistication with which they're able to both monitor and model aerosols, the interactions between weather, meteorology, and what's happening in the atmosphere. There has also been investments made in trying to improve the weather systems for the country as a whole. So I feel like the areas where we need more attention now is exactly the kind of questions that you're talking about. And hopefully, if there's folks here in the room who are interested in that question, there's also a lot of people in India who are willing to and want to work on exactly these types of questions. So I feel like we are on that path, and hopefully enough people can start paying attention to the problem and to these types of more sophisticated questions, which we now have the capacity and the infrastructure to really be able to do.
I'll just follow up on that, go back to a point that we made earlier, which is, I think as researchers, we have been very siloed in our thinking, but the same goes, I think, for how citizens perceive some of these problems. So to give you, I want to make this illustration through a story. So in several urban areas in India right now, major cities, I'm talking about Delhi and Bangalore and Hyderabad and Chennai, major water shortages. Part of this has been exacerbated over several decades as rising temperatures just cause greater evaporation of surface water sources, which are primarily what are used to pipe water into households. At the same time, so in a lot of these cities, the way that water scarcity has been dealt with is water rationing. So for instance, maybe every Monday, Wednesday, Friday, you get water for 2 hours in the morning and that's it. You make do with the water that you have. What happens when you go over and you need more water? You pick up the phone and you call a private water tanker. And they'll come and they'll fill up your tank. For many years, I was very curious about where the private water tankers were getting water from, because if there's water to be had, why doesn't it just come through the pipes? Now, it turns out this is a very interesting and complex story that has historical origins in agricultural subsidies in India. So farmers, as I'd mentioned, are a very vulnerable group, and they've been subsidized in a host of different ways over several decades. These are now completely politically entrenched. a major subsidy that they receive is near free or free electricity. That essentially translates to free water, because if I have free electricity, I can keep my pump on and just have water pumping out through my well 24/7. These are the folks outside cities that have now started selling water to private water tankers, getting water to cities, and that's how I get my excess water. So what this has created is this sort of loop where urban water shortages, which technically should be sourced from much more highly rechargeable sources like rivers and reservoirs, are now slowly dipping into groundwater, which is an extremely hard to recharge resource, only getting worse with increasing temperatures over time. This is one of those examples where I truly do believe that we are in a situation to make a win-win change. I can just make sure that the price of water is equal across space. It makes no sense to have water, which should have the same utility for everybody, to be almost free in one place and then infinitely expensive in another if I don't have access to water. And so there are these several sort of smaller changes that can be made. But to go back to my earlier point in how citizen thinking can become siloed, is that I don't think this connection has been made in anybody's minds. Like, I don't think someone sitting in Delhi picking up the phone and calling a private water tanker is aware that their taxpayer money, which subsidizes farmers outside cities, is the source of this water that they pay nearly $25 for a tank of water is from. And there's many ways in which we don't understand the several linkages. So I think this is also sort of a plea to kind of go back to this thinking on, we have better monitoring, we have better data, we have better technology, we have findings, and we have the know-how. I think as scientists, I think as researchers, we haven't done a great job of communicating these links to the general public. And there used to be a time when we could trust policymakers to accurately translate that information, and it seems less and less true now. And I think this can and should be part of our job moving forward, is to accurately translate information, to highlight these links for voting public to be able to expect better, as we all should.
Yeah, that's a fantastic example. And I think it really speaks to a transition in the policy world over the past decade from really thinking about, linear sort of policy outcome space to systems thinking. And within a system, there are entrenched interests, and there are people who might lose if they do not adapt to the new rules in play, or the rules create incumbents that have advantages. And that system thrives when there's informational asymmetry, right? When the tankers know where they're getting their money and they trust that nobody else can figure out the rules to their game. But there is then an incredible value in just laying out the constructs of the system so that everybody can understand, well, okay, here's everybody's role in this game, and now we can think about how to move forward collectively. So thank you for that fantastic example. I'm excited for your solutions.
Okay, I have another online question. So I know we touched a bit on solar earlier, but specific question of does the air quality in India impact solar generation potential? And if so, how significantly?
I'm okay to take that one if you guys would prefer. It's a big deal, right? So you all saw that picture at the beginning. We're almost into milligrams per cubic centimeter of air. And so that really does dramatically affect the downwelling radiation that reaches a solar panel and the amount of electricity that can be generated. So there is a potential win-win if systems can be implemented in a way that work on the ground for people in their communities to have them be much more productive.
Hi, my name is Palash Mukherjee. I'm an air quality researcher, having worked with think tanks and nonprofits in India. So my question is, as we've heard from the panelists, there's now some very insightful research coming out of India in the space of air pollution. So my question is that how should policymakers in India better leverage researchers and universities to inform effective policy. Perhaps you could touch upon the example of centers like this one and other efforts in the US to show the way forward. Yeah. Thank you.
Let me allow you all to self-select if you have great stories about collaboration with universities and community organizations.
I'm happy to start. I think that's a great question, and I think maybe we probably need to take a step back and sort of question the appetite that there is for that. Because I think sometimes what happens is that maybe researchers make conclusions that are not aligned with existing agendas. So in the context of India, for example, where there's known connections between governments and politicians and large companies that often win bids. So for example, with coal power plant generation in India, who owns a lot of these plants and what connections they have with the government, what appetite is there to invite a researcher saying, oh, we should absolutely phase these out and move towards something else. So I think there's a slight divorce in the reality that people in power want to be true and what should happen. And I think it sort of goes back to my point of if we were to be able to make some of these links and consequences clearer, I think in how we propagate knowledge and how we explain what we believe are the consequences of the status quo, I think we would be better served in a public that then knows what to ask for. So for instance, I think air pollution has become a bad enough problem now that people are demanding change. However, this change is once again very selective, right? If I'm in a district with a severe air pollution problem, my district administrator is forced to do something. But if I were in a district which is creating the problem, but I'm not experiencing it, there's less of an incentive. And there's nothing my administrator can do if the pollution is coming from somewhere else. So as Jen put it so eloquently, I think we need more systems level thinking and we need big picture thinking. I think it starts with educating people that I think air pollution, climate change, a lot of these environmental problems are unique in our history that we cannot think small. We have to kind of keep aggregating up. The more we aggregate, the better we can get at optimizing several different things. We can solve several problems in parallel if we're able to kind of zoom out a little bit. But I think we have to create the incentive to do that with better information. So I think as a start, that being said, there is precedent for some state governments in India to invite and to work with researchers. And I think it's actually taken quite motivated civil servants to invite that kind of scrutiny and discussion. There's an increasing number of civil servants in India who themselves have PhDs, often outside of India, and they kind of bring some of that know-how and network into India. And I've only seen this be a good thing. And I think it is something to kind of recognize and amplify a little bit to sort of show as positive examples. And we don't do enough of that.
Something really quickly. I think, a lot of times we also kind of label policymakers as a monolith. What do policymakers want? But what a city level decision maker will want from a researcher will be very different from a national level policymaker. And it will be very different from someone who's thinking about it in the regional context. So I agree with everything you're saying, but I will also add to it that as researchers, especially, we need to be thinking about, who is this policymaker that we are really referring to, and what is it that motivates them? And in instances where we do see better engagement and better, opportunities for work together at a certain level, we shouldn't shy away from that. Even a panchayat leader could be the right policymaker if they're willing to make the change. So I'll just add that.
Can I add one quick thing? So just on the side of agriculture, I wanted to tie these wonderful points with the comment of we're now in an era where we do have more data and more information. So for example, with agriculture, we can actually map a lot of these things that we care about using Earth observation satellite data sets, which all of a sudden now at a 10-meter resolution, we can map where crop residue burning is happening, who's adopting the happy seeder, et cetera, et cetera. And what we can now do as researchers is we actually can do impact evaluation to figure out what are the strategies that are actually working on the ground, where are the hotspot places with problems. And we've at least been noticing through our work that organizations, government, other development organizations are really keen to have these sorts of data to help make decisions.
All right, we've got just about to the end of our time. Thanks to you three very much for joining us today. We've been marinating in this intersection between air pollution, health, agriculture, climate, and efforts to solve this, this complicated web of problems. I want to leave us all with some takeaways to leave the room with. So I'm going to ask each of you, what's one thing that you would like our audience to take away from today's conversation? Pallavi, would you go first? Thank you.
I think the takeaway that I would really like all of us to go away with would be, we know the scale of the problem and we know what the solutions are, and that the argument for why this needs to happen, especially from a health perspective, is really, really clear. So to the extent that we can all be working together, both people who are in this room and everybody else outside, to try and think about the practical ways to translate science into things that will help us get to that better quality of life and better health, would really want us to go away with that thought.
That because I have about 80% the same point. So I completely agree. I think we're at a point where we know the problem, and luckily there are actual solutions out there that we know work. So I think really what we need to, as a community, put effort in is figuring out how do we actually scale these solutions, figure out where they work, where they don't, probably create a suite of complementary solutions to solve this problem.
I will also end on an optimistic note. I think there are solutions, but I also want to add a small caveat to that and say that we're not always lucky with win-win situations. And while action is necessary to combat climate change, to combat air pollution, what we should never forget and never ignore is that there will be groups of people who lose out. For instance, if I penalize farmers and stop letting them burn their crop, I'm effectively forcing them to maybe go to a more expensive option, a more time-consuming option. And we need to work through the compensation, and we need to work through the support for these particular groups that will likely lose out in a better way if we are to sustain any sort of climate change policy. So I think it is important for us to not forget that there are people who will lose out, to do a careful accounting, and if our calculations on the benefits of addressing climate change are to be believed, hopefully we have enough to go around to compensate those who do not directly benefit. But yes, I'm optimistic to see so many people here and to even have this panel, and the fact that there is an interest and a sustained motivation to address these issues. And so I'm excited to sort of see where that takes us.
All right, fantastic. On that note, let me invite Nikki back up to close out our session.
Thank you, Jen, for moderating that informative conversation, and to Pallavi, Meha, and Meera for bringing your expertise, passion, and actionable solutions to this conversation. And to everyone who joined us today, thank you for your interest and excellent questions. We read all the feedback we receive from our viewers, so please take the survey linked on our webpage to let us know your thoughts on today's programming. The conversation was recorded and will be available to view on our webpage now. For more from our team at the National Academy's Climate Crossroads Initiative, including future Climate Conversations webinars, sign up for our newsletter and visit our webpage by scanning the QR codes on the screen. And finally, a special thank you to Sananda and Ram for making this possible, and to my National Academies colleagues who supported today's event behind the scenes. Thank you all.